The broadcast is now starting. All attendees are in listen-only mode.
Welcome, everyone. This is Mike Wall for the May meeting for the Oregon Data Community, and I hope that you are all well and healthy during this time. At this time, I'd like to introduce members of our leadership team who are online, and they can pop on and say hello. We have Arnie Rowland, Paul Turley, Dr. Michael Curry, and Vern Robbie. You all want to say hi?
Hello, everyone.
Howdy doody.
Give me an opportunity to take a strategic drink. Telling everyone about this is my frozen water from my 1940 Frigidaire that I plugged in for the first time this week, and it worked just fine, except it froze the water, so I got to turn it down a little bit. Anyway.
In the year 2100, I don't think that any refrigerators sold in 2020 will be in operation.
Probably not.
8 years from now.
We'll have to live in a house that's over 100 years old too. So anyway, so welcome to the group. Welcome to the meeting tonight. We've got Brian Stork speaking on unit testing, and then of course we have Paul Turley speaking on data modeling. Should be a pretty darn good group. Brian is first time speaking here, and everyone here has heard Paul Turley before, so it should be an excellent presentation. One of the things I wanted to talk about tonight is, let me share my screen. If that's going to work. I don't have commands. Let's see, I think I need to be the, here we go. All right, I didn't prepare properly. I've got all sorts of stuff here. I was writing documentation. I was doing all sorts of crazy stuff. Anyway, what I want to talk about is some of our sponsors here. And so ServerLogic, who did, they have been a long-time supporter of Oregon Data Community. They are a boutique hiring IT consultancy down in Tigard area. And they've come to our meetings a few times, and they would be happy to talk to you. So right here, we've got their website, and we've got a phone number here, right here, so you can give a call and talk to them. And once again, want to thank ServerLogic for all their support. They've supported us for at least 2 or 3 years now, I believe. Another one, especially proud of since I work for them now, is Pragmatic Works. Along we have Paul Turley working for Pragmatic as well. Pragmatic has been faithfully giving us the 1 year of training to everyone. In addition, last month we had the opportunity for free trainings for anyone who's been affected by the virus. And in truth, they're just giving out free training to anyone who's not working, because that's the type of company that Pragmatic is. Anyway, so Pragmatic, obviously they have the training services, and then they have the consulting services, and that's the side of the house that Paul and I work for. In addition, Redgate. Tonight we will be giving out to a lucky raffle winner a copy of SQL Prompt. Redgate also has been a longtime supporter of Oregon Data Community, and we certainly appreciate all of their help. And of course, we were talking about the odds, but Past Summit is coming up. So it's going to be at the beginning of November. It's going to be down in Houston, which is a little bit different because the Washington State Convention Center is closed for remodeling. So I'm not sure if any people are interested in going to Summit. You can certainly raise your hands. I know that I submitted. It should be a great event if it happens. We were talking that it'll probably be at 30%. Another event that's near and dear to our heart that we hope it will.
And that's just a guess. That's not based on.
That's not based on any sort of information.
Yeah. But any rumors?
Any rumors? We'll just have to see. So we secured the number 1,000 for SQL Saturday. So it's time to start talking about SQL Saturday. So as far as we know, we are planning to do SQL Saturday Oregon, number 1,000. And you can see here it's going to be on October 24th. It will be at the University of Portland again. We have everything in place. We just have to hope that we are allowed to have in-person events. And I'm sure that a lot of the people in this room have been to SQL Saturdays before, especially ours, and they know how much fun it is and what quality of speakers we have. And we are going to make sure that we have the same quality of speakers this year as we have in the past. If you are interested in speaking at SQL Saturday, it would be very easy for you to do this. There is a section where you have to sign in right here. You have to become a member of PAS. And if you're not a member of PAS already, you should do that. And then you have an opportunity to set up a speaker profile. And then at that point, you can create sessions, and you can submit up to 3 sessions, or I think that's the limit. You can submit 3 sessions for us to vote on to see if you get to present. And then finally, wanted to direct you once again to our Oregon Data Community webpage. One of the things that I bring up occasionally in these meetings is the fact that we have all the other regional user groups. So Brian Stork, here's his picture right here, our speaker, already spoke today at noon for the Salem SQL Server group. But we make an effort to make sure that we have pretty much all of the Pacific Northwest, including our friends up in Victoria. Their user groups are on here, and all these links work. So if you are interested in talking to one of these groups, especially in the days of remote speaking, this might be another opportunity for you to speak at one of these user group meetings. As I always am saying, is that I know that the coordinators for the user groups would be more than happy to have up and coming or experienced speakers present at their groups. So just have to reach out and talk to them. So click on this link and that'll get you the right information.
Also, Michael, let me add,
Oh, yes, sir.
attend their meetings. You don't have to be speaking. You could look to see
Right.
what their topic is and attend their meetings online.
Exactly. I mean, we have a couple people last month who were able to attend from Bend. So this is it's a setback, but it's also a rare opportunity that you can actually now attend a lot more things. I know that I am scheduled, I'm going to be attending a couple meetings, some friends of mine in Germany. Now I'm going to have to be up at 3 or 4 in the morning, but still, it should be fun. Next month, Jessica Aguilar is going to be speaking on, she's going to be doing a breakdown between Power BI and Tableau. And I think in July, I'm going to be speaking on Polybase. So we've got some interesting presentations coming up. As always, if you have some ideas, if you'd like to speak at Oregon Data Community, please don't hesitate to let one of the people in the group know. You can use the leadership alias, which is leadership@oregonsql.org, in order to send a message to every one, the people I just listed off, myself, Vern, Paul, Arnie, and Michael Curry. We'll get your message and then we will respond to you. So I think that's about it. I'm going to let one of the other members of the leadership team take the floor for a few minutes if they have something they wanted to talk about.
I think you've covered it from my perspective, Mike.
Okay, well then let's get right into it. We've got Paul talking already. So again, we're going to have Paul Turley talking about data modeling solutions for challenging data modeling problems.
All right, thank you, Mike.
Shut off the camera.
All right, and I think I can make myself a presenter. There I am, and I can show my screen. I just need to figure out which screen to show. Let's try that one. That's not the right one. Let's try this again. Oh, I'm so sorry. Let me presenter. I need to share my main screen, which is, darn it. All right, tech support. I need to share my laptop screen. When I'm clicking the share screen button, it is actually just sharing the GoToWebinar viewer.
The screen's just too big for you to find anything to click on, Paul.
You can see your screen. Click to stop sharing. I'm assuming that you're seeing the GoToWebinar viewer right now, or what are you seeing?
We can see the ER model.
Oh, okay. Well, that is my lap. I'm accustomed to it actually puts a frame around the screen. So anyway, sorry about that. Let me just go ahead and kick off with my opening slide deck. Now this presentation was prepared to be an hour-long presentation, so I'm going to move through some things rather quickly. I'm going to be working in Power BI Desktop, but we'll be talking about using the data modeling tools that are related to analysis services tabular models. So this applies to both analysis services models as well as Power BI models. And this is really kind of a 200 level session. I'm assuming you have some data modeling experience. The concepts are introductory, but I'm going to get into some moderate level topics. So when we talk about building business intelligence models, you know, in the world of kind of spreadsheet data presentation and using products from a number of other vendors, the approach generally taken is that data gets flattened into a single table, a single spreadsheet. And the reality is that the world is not flat. Sometimes flattening data into a single result set does not meet challenging analytic and reporting needs. So let's take a look at just a real quick snapshot of some data. Here I have some customer sales data. If we break this down, you'll see that I've got 3 different date columns in what could be a spreadsheet or this flattened view of my data. I have some customer information consisting of a couple of columns. I have product information consisting of categories, subcategories of products. And then I have 3 columns here that have numeric values that could be aggregated and could be the basis for, let's say, time series measures, year to date, year over year, month over month, those kinds of things. But in this flattened view of the data, there's only so much that we can do with that. So we'll back up a little bit and introduce the concept of a star schema or a star model. Now, if you've been exposed to analytic solutions or BI solutions in the past or mainstream data warehouse design, you're probably familiar with this concept of the dimensional model, where we have facts in the middle and the facts are related to dimensions. There we can see the materialized view or the actual implementation of a dimensional model. So the dimensional model is really considered to be a general best practice, but it's not the end-all be-all to data modeling. Why do we use dimensional models? It improves performance. It can provide more accurate results because data has to be organized so that it fits into a star, but it's not an absolute for simple attributes. What we mean by that is if I go back and look at this flattened view, it might be okay to have the product name in the same table. It may be okay to have the order date in the same table rather than in a separate dimension table. But those are rare exceptions. So where did this dimensional modeling set of rules come from? Who defined them? And if you've heard me speak before, I often talk about these people, particularly the man sitting in the middle down up front. Now, this family photo is not to be confused with this family photo. The group on the left are data professionals. The group on the right appeared in a movie called Step Brothers, even though they might look similar. We're talking about the Kimball Group. Now, this is actually a consulting group that was in business for about 30 years. I equate the Kimball Group to a success sitcom, like All in the Family or Friends, Seinfeld. They had a good run. They left on a high, and then they went off the air. They did that about 6 years ago, essentially after writing the book on this topic. What did the Kimball Group do? Well, they defined a process that really consists of some very simple high-level steps. One is that you select a business process to analyze. Figure out what your objectives are, what we're focusing on. What's that business process? Is it inventory? Is it sales? Is it forecasting? So we focus on a business process. We declare and understand the level of detail necessary to analyze this data. We call that the level of grain. And grain applies to dimensions. So you think about the dates, you know, how low do we need to go? You know, orders are placed and could be recorded in a database, you know, as of a minute, as of a second. Is it important to be able to analyze data at that level of grain? Maybe we can bring it up to a day. Maybe we only need to be able to analyze and aggregate that data by week or by month to meet our reporting needs. And then we identify the facts. What are the things that we're actually reporting on? What are we counting? What are we aggregating? What are we summing or averaging or comparing across different periods? Now, there's a whole process. If you go read the Data Warehouse Toolkit, and there have been kind of modern takes on the works of Kimball, there are several steps involved, and we're not going to get into all of those steps and how you actually cleanse that data, how you stage it and transform it and bring it into a dimensional model. But you know, there are exceptions to the simple rules of every dimension related directly to a fact. We've got many-to-many relations, we can have bridging tables, we can have disconnected measures, disconnected dimensions. But the final step in this list I think is very notable, and that is that we have to continuously balance requirements and realities, meaning that we work in iterations and we discover as we go. It's very difficult to get all of your requirements up front and to fully understand and be able to code to those requirements. So it's an iterative process. That's often a balance and a trade-off between one, flying by the seat of your pants, which often doesn't go well, and two, waiting until all of the requirements are absolutely well defined before we can get started. All right, so some concepts here. Role-playing dimensions. So let's take a look at some examples of role-playing. This is a set of data that I've used in the past that I think is a really good example of a simple role-playing dimension. If we're keeping track of airline flights, well, what happens on a flight? Well, the airplane leaves from somewhere and it lands somewhere, hopefully. And so you think about the concept of an airport. What role does an airport play with regard to a flight? Well, it's a place where we load passengers up and then the airplane leaves or departs from that place. And then another airport plays a completely different role, and that's where the airplane lands and the passengers get off the airplane. So an airport can have two different roles, the departing airport as well as the arriving airport. Same thing with dates. We think about sales orders. Well, with respect to a sales order, what dates do we care about? Well, we care that the order was placed on a certain date, so that's when it was recorded in our system. Great, we have an order and it was placed on the 13th of May. When is it due to be delivered? So we have a schedule date or a scheduled due date, and then we actually have the date that the order was actually delivered. So it could be 3 dates, or it could be multiple dates. Well, a role-playing dimension suggests that we have a date that is wholly separate from another date, and we may have a separate table for order dates versus delivery dates versus the actual date that the order was delivered. Due date and delivery date, that's what I was trying to say. So this is an example of where there may be 3 separate tables that play those roles. In a transactional database, we wouldn't do that. In an analytic database or semantic model, we absolutely would materialize data multiple times when it plays different roles. Maybe, maybe not. We're going to talk about that. But it's important to understand this concept. Another important concept in semantic modeling is this idea of directionality of filters. And I'm going to show this to you here in just a minute. Bear with me just a second. My wife is yelling at the dogs. Always well-timed. So the direction that filters are applied within a semantic model is important because it is costly to filter tables on both sides of a relationship. and it's something that should be used very sparingly. So we'll go back and we'll take a look at this. But in this, the screenshot of my diagram, you can see that in this Power BI model, I have a, let's call it a fact table called case details. And I want to be able to filter that table based on a selected country or state. So if I were to select a state, let's say from the country state table, the directionality of this filter, regardless of the cardinality, but the directionality of this filter suggests that if I group by, filter, or slice by a state or country in this case, that's going to filter all of the records in the case details table. Likewise, let's say if I were to select a country from this population by country table, that filter would need to flow from this table, through this table, through this table, and then eventually filtering my case details table. You can see that it's necessary to establish filters that allow that to flow. So it may be necessary to use bidirectional filtering at a performance cost. So we'll take a look at that as we get into actual modeling. And this is one way that we can facilitate many-to-many relationships. All right, I need to move pretty quickly because this is the shortened version of a presentation. So let's just take a quick look at a data model and some of these concepts. So here you see my online orders table. I have two fact tables. We have store sales and we have online sales. Let me pull product down there so we can just see those side by side. And you can see that online sales can be ordered, they can be due, and they can be delivered. You can see that the directionality of these tables, denoted by this arrow right there, shows that when I select a date, it's going to filter the online sales table. If I were to select a field from the online sales table, that would not filter my date table, because that's not necessary to meet my reporting requirements, and I don't want to bear the cost of creating a bidirectional filter, which I could do right here just to show you how I would do that here in Power BI Desktop. Okay, again, not a reporting requirement to say, hey, let's go, select a customer and see the dates for which they had orders. I'm not going to save this file, so I'm not going to worry about changing that back. Well, so we have another interesting anomaly here, and that is that both store sales and online sales can have a geography element. So you can see that online sales have a customer, and that customer, it has a location, therefore the geography table is relevant. Here you can see that in the customer table, I have a geography key, and you can see that that is related to the geography table because that essentially is my primary key in that geography table. Yet, stores have a location, therefore there is an implied geography from store sales through store to geography. The problem is that since geography can be related to store sales in two different paths, the geography could be related to both store sales and online sales through two different paths, I cannot enable this relationship. So let's go make that active, and you'll see that I get a warning message down here that says you can't create a direct active relationship between store and geography because that would introduce an ambiguous relationship, meaning that there could be multiple paths to filter geography to store sales because of customer. Store sales have customers, customers have a location. Geography could be related to the store sales through customer, and it could also be related through the store tables. That's a problem that I need to solve. So let me jump back to PowerPoint, and we will You know what? I'm actually just going to talk through this just in the interest of time. And let me jump over to the measure where I've actually resolved this problem. We're going to look at store sales by geography. Store sales quantity by geography. So because I can't rely on this relationship right here, that can't be active, I need to infer a relationship from a measure field or a numeric field in store sales from the geography table. In other words, if I group by or I filter by a geography, I need to see the related store sales. So I'm going to have to infer a relationship here. So let's jump over to the page where we're actually seeing that working. So you can see that here I'm just grouping by the continent, and I am seeing the quantity of sales for that continent. How did I do that? Well, I'm using a measure called store sales quantity by geography. And if we go take a look at the definition of that measure, which is right there, I essentially have to do it programmatically. And by programmatically, I mean I have to write some DAX, which is the query language of Power BI and Analysis Services Tabular. So here I'm using a function called treatAs. What that means is as we are calculating the sum of the store sales quantity, what I want to do is I want to go get the collection of geography keys from the geography table, and I want to treat that set of geography keys as if those were the geography key values that were selected for my store. That's what treatAs does. It says, take this collection of values, the stuff that I've selected from a column, and go cast that onto and filter a separate column in another table. And so that's how that works. So I can't handle that within my model. I have to handle it within a DAX query or a DAX expression. All right, so who needs relationships anyway? That's just a lesson in life. We're going to talk about using disconnected tables, meaning that I'm going to create a table for the purpose of selecting something or grouping something, and then I'm going to write some measure code or DAX that utilizes that table, even though I don't have relationships connected to that table. And that can drive dynamic calculations. And internally within DAX, we use functions like if and switch and has one value to be able to facilitate these things. So I'm going to show you some disconnected tables within my data model. Here you can see that I have 3 tables that I use for various things. I'm going to, let's see, I'll show you a peek of this selected measure period, and then we'll take a closer look at the selected effective date. I'll jump back to my model and show this to you. So, again, tables floating out in space. They're not related to anything. If we go and take a look at one of those tables, if we look at the selected measure period, actually created this table using the enter data feature in Power BI. In other words, it doesn't have a data source. I just simply opened up a grid and I typed some values and that became a table. And that's a very convenient way to create a reference or lookup table like this. So you can see that I have a single column called period with values current, month to date, year to date, same period last year. So these are obviously the titles of time series calculations that I want to be able to use for reporting. So I have a number of measures that I've already created that perform my month to date calculation. So here's online sales quantity. Let's not look at the fiscal periods, just not to muddy the water. Online sales quantity year to date. That's a simple measure here that uses the total YTD function. Same thing for month to date, total MTD. Same period last year, uses the same period last year function. So I'm simply kind of creating measures that utilize these internal time series DAX functions that do this date magic as I'm aggregating these values. But what I would like to do is be able to let the user say, here's a visual, and I want to put a number onto it, and I want to dynamically say that's a month to date, or it's a year to date, or it's the same period last year, or some other time series calculation. So let's jump over and take a quick look at my time series. That's not the one. I'm looking for my dynamic sales quantity time series. So here you can see that I have a slicer that's driven by that disconnected table. So right now we're looking at, let me zoom in so that I can interact with that right there. So you can see that I have a date hierarchy right here. This is my order date, year, month, and date. And for each of those periods, you're just saying the current quantity value. That's simply the sum of quantity across each of those periods. But if I wanted to see that as a month to date, I can dynamically switch out the measure right here just by selecting a different value. And you can see that that is indeed a month to date, which is fairly obvious because you can see that it accumulates. If we were to go down and get to the end of January, you would see that those values start over again and they're accumulating again for each month. So that is in fact a month to date. If I were to look at a year to date for January, you'd see the same numbers as the month to date, but the difference is, of course, that when we move on to February, the numbers would keep going up. And so how do we do that? Let me actually select a couple of these just so you can see that in this matrix where I've actually grouped by this period, you'll see one column per each of those dynamic measure values. All right, so how do we do this? Zoom back out, and you'll see that I've created another measure called online sales quantity selected period. We look at the DAX for that. You'll see that what I'm doing is I'm playing a shell game with these measures that I've already created. So I created this disconnected table called selected measure period. It only has that period column. So based on the period that I've selected, which is returned using the selected value function, I'm going to perform a switch. Think of a switch as nested if statements. I'm going to say, well, if the selected value is current, then go return the value of the online sales quantity measure. If the selected value is MTD or month to date, then return that measure value, and so on. So I'm able to, with a little bit of code, I'm able to dynamically switch out and modify the behavior of a measure. All right. All right, so we talked about disconnected tables, and we did take a look at the use of the switch statement, which, sorry, let me go do that. I'm not going to talk about direct query and composite models, but I am actually going to switch gears a little bit and just talk about something on a related topic. Let me do this. I'm going to wrap up my demonstration with a really quick demo of a disconnected table. And then I'm going to switch topics really quick to wrap up. So I've created another table called select effective date. And if we look at that table, you can see that it's actually just a copy of my date dimension table right there that only has one column, it just has the date. So for the entire series of all of the records in my date dimension table, which is a contiguous range of dates beginning on January 1st of 2007, I think this data goes to the end of 2012. I just have one record per date. Now, why would I do a silly thing like that? And if you go out and you look in my data model, you can see that it's not related to anything, it's just sitting there. But that is a date that I want to be able to select. A few years ago in a training class, somebody who works for an insurance company came up to me, and it was during a Power BI class, and he said, I work for an insurance company and I want to be able to allow an insurance adjuster to select a beginning date and an end date, and I want to know how many claims were open that have not yet been closed in that span of dates. In other words, the claim was filed, the claim was opened on a date on or before the first date that I select, yet within this period of time, the claim had not yet been closed. And so apparently insurance adjusters are watched pretty carefully to try to close these claims as quickly as possible. So I want to be able to see how many orders are pending. So this is a similar scenario. I'm saying, all right, I've got customers who have placed orders and they're scheduled for delivery, but they haven't yet been delivered. So Amazon hasn't pulled up to the door, they haven't delivered my stuff yet, and so how many orders do I have that are still sitting out there? So let's go take a look at how we could make that happen. So I've got a report page here called Orders Pending Delivery. You can see that I have a range slicer where I can say, all right, so between this range of dates, I want to see how many orders are pending delivery, have been placed but have not yet been delivered. 799 orders between October 10th, 2009 and December 28th, 2009. And then here by date, I can see how many orders are actually sitting in the queue. So how did we do that? We have a measure here called online orders pending delivery. And I'll also point out that on the x-axis on this column chart that I'm using the date column from my select effective date. Remember, that's a table that's not related to anything. So I'm going to have to write some code to get this to work, because naturally that's not really going to do anything. And this is what it does. So I'm saying, first of all, I need to figure out what effective date is currently in scope. So let's think about that. If I'm visualizing this data in a column chart, for every single point on the x-axis, this code is going to be called. So if right now I'm sitting on May 13th, 2020, my selected effective date is going to be May 13th, 2020. The min function is necessary to reduce a potential table full or a list of values down to a single value. Min doesn't otherwise really return the min of anything. It just guarantees that I'm always returning one value. And then I want to calculate the count of rows. Remember, I'm interested in how many orders I have, and every order is a single record within the online sales table. But I don't want that table to otherwise be filtered. So I want to remove all filters that are already in place. That's what the all function does. And then I'm going to say where, if I'm thinking in SQL, where the order date is less than or equal to the selected effective date. I'm going to have to zoom out to get to the bottom of my code. And the delivery date is greater than my selected effective date. So anything in that range that meets that criteria. So since I'm at the end of that demonstration, let me ask if there are any questions. I'll give you a few seconds to respond to that. Well, I'm going to switch gears on you, and I'm going to show you that relationships are not always necessary. Here you can see that I have, yeah, go ahead.
I said no questions yet, so go ahead.
Oh, thank you, Mike. So here you can see that I have a rather rich Power BI report page where I've got all kinds of visuals. You know, I've got a slicer here where I can select my fiscal year. And I just want to point out that when I select a fiscal year, it filters everything on the page as we would expect it to. I have a ring chart here that's showing measure values by product category, et cetera, et cetera. You can see that there's a lot going on this page. And one might think, oh my gosh, I've got a fiscal date range, I've got my calendar dates, I've got some product information, I've got some geography information. Must be a lot of related tables here, right? So let's go take a look at a diagram of this model. Oh my gosh, with one exception, I have no relationships at all in this model. And that relationship is only there because I forgot to take it out. And well, how is that possible? How is it possible that Power BI is just working and it's grouping and it's aggregating and it's slicing when I have no relationships in my model to support that? Well, let's take a look at the measure that I used. And I need to go remind myself which measure I used. And I think I created two measures that do this: online sales quantity. So if we go and take a look at the online sales quantity measure.
Paul, it looks like someone's interested in the PPIX file.
Okay, and I will answer that question in just a second. So what I've done is I've just simulated all of these relationships. So essentially what I'm saying is I'm not going to rely on filters to be propagated through relationships. They happen to not exist. But I'm just going to programmatically go create or infer a relationship by saying whatever customers are in scope, if I've grouped or filtered on a customer, take that collection of customer keys and just push that over and filter the online sales table based on its customer key, and so on. Order date, date key to the order date key in online sales, from the product table to the product key. So this is not necessarily a best practice design pattern. I'm not saying that we don't ever need to have relationships. They exist for a reason. But this kind of technique gives us the freedom to not rely on those relationships, to make exceptions to the rule, and to write a little bit of DAX and achieve very exacting results. So to answer the question, will I post the PBIX file? Yes, I already have. So if you go out to my blog under presentations, and I'll show this to you right at the end, then you'll see that I actually have both the slide deck, and there are template copies of these two Power BI desktop files. I deflate them into template copies. Oh, and I'm sorry, they're not template copies. I do actually have the data in here. But yes, they're out there under the presentation area. I want to show you one more thing, and then I'll just show you where that is on my blog. Power BI is a tool that really started out 7 years ago as a self-service BI tool. In other words, as Microsoft was really kind of looking at the industry and saying, wow, Tableau's doing great, Qlik's doing great. There's these companies that are making these self-service analytic tools that are really focused on the business user rather than the IT enterprise BI story. Let's make a tool that appeals to that audience. Let's optimize it and simplify it and make it easy for business users to be able to do their own BI. Well, what about those of us who work for IT shops who deal with large volumes of data, where governance, security, scale, those things are paramount in the work that we do? Well, Power BI has really been moving in that direction, and that is very quickly coming to fruition. Now, something that you may or may not know about Power BI is that the data modeling experience and the technology behind this data model is in fact SQL Server Analysis Services. It's just a little mini version, or it's been a little mini version up until recently. If we go to the Power BI service, where we've deployed a PBIX file with data in it, that data set is actually an analysis services database. Now I'm going to jump over to SQL Server Management Studio, and I'm going to show you, this is actually a real client's environment. I'm not going to show you any sensitive data, but I am actually working in a real environment. Let me zoom in again. That was weird. Zoom, it just zoomed out all by itself. Okay, stay. So aside from my on-prem SQL Server and my Azure SQL databases here, you can see that here I am using Azure Analysis Services. So that's, real enterprise scale analysis services. But here I have an analysis services connection in SQL Server Management Studio to a Power BI workspace. This is using what's called the XMLA endpoint. And what the XMLA endpoint is that's the way that things connect to the analysis services instance or databases that are stored inside the Power BI service. Well, what can I do with that? Well, we can query it. So I told you that this is real data. It's for Forsyth County Schools, and I'm not connected to the right place. Let me jump over to, actually, let me do it this way. I think my query timed out. Okay, and so these are all of the schools in their Power BI data set. Why am I getting an error? Okay, I'm going to end that demo. I think my connections went latent, and I would have to reconnect. So I'm not going to bother doing that. But I actually have the ability now, using the XMLA endpoint, to be able to deploy directly from Visual Studio, where I have a SQL Server Analysis Services project. And so I've done all of my modeling work here in Visual Studio in this Analysis Services tabular project, and I can deploy directly out to that endpoint, which means that Visual Studio now becomes my development environment with version control, application lifecycle management, the ability to merge and branch my code and to share and collaborate among different developers, capabilities we haven't had in Power BI in the past. And then I can just deploy this directly to a Power BI workspace. And I now have an enterprise class tool that I can use for my data modeling. So with that, I believe that I'm out of time. Let's just come back and see if there are other questions. I see part of a question here. Mike, help me out with this.
Yeah, it's so it says treat as appears to operate as a join in SQL DML without creating an actual foreign key in SQL DDL. Is that a reasonable way to describe it?
From the perspective of SQL in a relational database, I would say that that is an accurate conceptual description of what treat as is doing. Keep in mind, we're talking about two very different technologies here. But yeah, I mean, we're talking about relationships and keys. And so, yeah, conceptually, I think that it's the same kind of thing.
Okay. Well, thank you, Paul. That was great. You got a number of congratulations.
Thank you. Let me fully answer the question here just by going to my blog really quick. So let me grab a browser window, and I'll just show you where you can find this. So if you go to my blog, over on the left side, that's at SQLServerBI.blog or SQLServerBIblog.com, and just go down here to presentations. So this is actually the most recent presentation that you'll see at the top of the list right there. And so there's the presentation deck saved as a PDF, and then these are the PBIX files that I used. All right, well, with that, thank you very much. Mike, the time is yours.
All right. Well, thank you very much. I just wanted to, I was chatting with one of the people who is on our, I can even show my web screen or webcam. Anyway, chatting with one of the people who's attending the meeting, and I wanted to put up this one page again from Pragmatic Works because I thought it was important, because I know that they're still doing this, and we got everyone's here. The fact that Pragmatic Works is still offering, they're offering free training for anyone who's been affected by the virus with 6 months of free training. And again, so send an email to training@pragmaticworks.com. And I know that the nice people there would be more than happy to set you up with an account. Pragmatic Works has an excellent library of different training courses. It's more of just, it's finding time in the day to go through all of them. And the other thing, if you wanted to post in the questions thing, what are you doing to work on training? Kind of curious what people are doing to skill themselves up. I mean, I know that people are busy with a lot of different things, whether they're working or not, but I'm curious. I think it'd be interesting to know what people are working on in order to use this time.
Yeah.
And I understand.
And I'll just, Mike, just a point about the free training, and I'll paraphrase Brian Knight, who's the CEO of Pragmatic Works, when he introduced this. They've been talking about it in our employee meetings. Brian essentially said, you know, we're on the honor system here. We want to help out. And, you know, so anyone who has been displaced or furloughed or otherwise affected by the outbreak, we want to help out by offering free training. You know, that training would normally be, I mean, that's how they generate revenue. They would normally charge for that service, but, you know, we're just going to trust people to be honest with us. You don't have to prove that you've been laid off or lost your job, but, you know, please, you know, be forthright about that, because, you know, it's otherwise money in their pockets, but they want to help out.
Yeah, absolutely. So that being said, let's get on to our main speaker for tonight, Brian Stork. And I know that he has some great stuff to talk about. It looks like he's been testing for a very long time. So Brian, are you ready?
I think so. I need to be able to share my screen. I don't see that yet.
Yep, we're coming there. We got that. You are now the presenter.
Outstanding.
I'm going to cam myself off.
So, hi everybody. Thanks for driving all the way out to Portland to see this presentation. My name is Brian. This is my first time presenting here. I've given this presentation a couple times before. It is something I'm really passionate about. Database unit testing is very near and dear to my heart, and the technology that I use is the tSQLt framework. I absolutely adore it. I think it's great. I wanted to start off by sharing with you something that I had just recently learned about SQL Server. I am a database engineer. I am not a DBA. I like to solve the interesting problems with moving the logic through, and I'm always trying to figure out what is exactly SQL Server doing behind the scenes and how does it do it. So I'm going to show you, this is what I call my old dog new trick. This was something that was kind of a surprise to me, and maybe it's going to be a surprise for you too. I'm just going to show you, I'm going to build a table that has 3 rows in it. We'll execute that, and hey, I've got 3 rows. Now, this is just 3 rows. If this were hundreds of millions of rows and I needed to empty this table very quickly, I would probably use a truncate table statement. And I've always believed, I think somebody told me a long time ago, and I've always believed that truncate table was so fast because they said it's an unlogged transaction. It doesn't hit the transaction log, it just destroys the table, which is cool. But what it means is if you do begin transaction, truncate the table, and then try to roll back that transaction, you're out of luck because it doesn't hit the transaction log, so it can't be rolled back. Now, by executing that, I've just deleted everything off of my test table. And as it turns out, I was wrong. Truncate table does actually hit the transaction log, and you can roll it back. I don't know if that is news to you. That was news to me. I learned a couple of months ago from Brent Ozar post. Really surprised me, but it was neat because it lets me know that I still have the ability to learn new things. And also it kind of relates to this because the unit test we're going to be talking about, maybe you need to truncate a table, and it would be neat to know that you're not actually going to truncate the table during the test because you can roll that back. So today we're going to talk about what is available in tSQLt, and I'm going to give you some pointers on how to write effective and informative unit tests. It is the year 2020, so I hope we are no longer discussing whether or not we should be unit testing. we should be discussing the best ways that we can do it. The value for unit tests, it's amazing, it's fantastic. So what we're going to go over in this presentation today, I'm going to tell you why I am talking about unit tests. We will briefly discuss what the anatomy of a unit test is. We will say what makes for a good unit test. And I will go over some of the tSQLt features. I'm not going to hit them all. I'm going to hit the ones that I use the most, and I hit them the most because they're fantastic. They're just great. All right. Why am I talking about test-driven development and database unit testing? A few years ago, several years ago, I worked at a medical company, and there was a developer there who was really all about test-driven development, and he gave presentations on it. We were Microsoft shop, so he was talking C# stuff. And I watched the presentation, and I thought, this is really fantastic, but your C# code creates these little executables or DLLs or whatever, and you can just build them and throw stuff at them and check the results, and then they disappear when you're done. And the database is not that. The database is purpose. The job of the database is to remember what has happened to it. And a lot of times, back then anyway, a lot of companies, my company included, did not have the database in source control. We couldn't just build one out of the source code and run tests against it and then destroy it when we were finished. Hopefully these days our databases are in source control and we have methods of building them. That is kind of a prerequisite to being able to do this. But I pretty much just wrote it off. I said, test-driven development and unit testing is not for the database. If you think that it is, you really need to learn a little bit more about what databases do. A few years after that, I'm at another medical company, and we get a mandate from management that says we are, in fact, a test-driven shop. And even though we haven't done it yet, we need to research and figure out if there is any way we can do test-driven development with the database. I told my boss it was a fool's errand, and I listed off at least 100 reasons why you cannot unit test the database. Part of the problems are, like, you could begin a transaction, run your test, and roll the transaction back, but then how are you going to record the results of what the test was? Because it got rolled back in the transaction. It's not like you can even print it out or display it or anything. But he sent me off on the errand anyway. And I found a few that were pretty lackluster, some that were downright horrible. And I stumbled across this tSQLt. And the main developer is a guy named Sebastian. He's a doctor. I've met him at a couple of past conferences. I fanboyed on him really bad the last time. I think I scared him just because I was gushing about how awesome his product is. That company, by the way, we immediately started implementing, after we saw what it could do and saw that it would work, we started implementing test-driven development for all new SQL code. So all the new features got to unit tests before they were released. And as time allowed, we went back and tried to retrofit the older procedures so that they would have unit tests as well. I will say that when I started at that company, before we had the unit testing, release nights were an all-night white-knuckle affair. And we were terrified that we would have to roll back the product because that was an all-day affair. And by the time I left, releases were boring. I wasn't invited, and I didn't really even know that they were going to do it. And a lot of that had to do with the fact that we put in a lot of automation and a lot of testing. Having that little adrenaline when there's a release and that peace of mind, really insanely valuable. So I've been working at the University of Washington for a couple of years, and just recently I had to go in and remove about 45 views or so from our database, and we had customers that needed to use these views for different things, and I was replacing them with something else. And I got the story and I started working on it. I modified all my tests to make sure that they worked, and I released the code. And I realized on release night, when we released it, that it wasn't a big deal to me. I wasn't really stressed out. I wasn't worried. And I thought, this is really nuts. This is crazy. I ripped 45 schema objects out of my database, and I'm releasing it to production, and I'm not even worried. And the fact that I wasn't worried at all was, to me, a huge deal. I mean, when do you ever have confidence like that with the database? It's crazy. And it's all because we have these, I had a bunch of data contract tests, and I'm gonna show you what some of those look like. Some data contract tests around what was going on. So I was very confident that my customers were still going to get the things that they needed, even though I had done all of this refactoring behind the scenes. So let's talk a little bit about what a unit test is. The basic anatomy of a unit test, it consists of 3 parts. At the beginning, you arrange, in the middle, you act, and then you assert. The way that I like to think of it, and it's actually not a bad naming convention, say, given these conditions, when I perform this action, I expect these results. And that arrange is, given these conditions, you're going to set up everything you need for your test. Then you're going to act. This is where you exercise the feature that is under test. And then your assert is where you check to make sure that it has done the thing that you wanted it to do. What makes for a good unit test? A lot of people get hung up on this because, especially with SQL Server, we tend to build monoliths. We will build gigantic stored procedures that do a ton of things, and we tend to think of that as a unit. I like the term the unit test because a unit is an arbitrarily small. You want it to be as small as possible. It's an arbitrary unit of work. It's just a small piece of logic, and we want to try to test the individual pieces. And a lot of people get hung up on that because what we're going to talk about is some dependency isolation that looks like we're not testing the whole procedure, and in fact we aren't. We just want to test small units of it. Not to say that there isn't room for those other tests, the larger tests, those absolutely have value, but you do want the unit test as well. The unit test is your first line of defense. You want to make sure all the little pieces are working. So the first part of our unit test is it should be order independent and isolated. That means that the test should not rely on the database to be in a certain state before it runs, and it should not change the database when it's done. It should be completely benign. Shouldn't make any changes at all to the database. You should be able to run it in any order, and it doesn't need anything. Everything that it needs, it should bring with it to run the test, and it should disappear when it's done. The test should be atomic, which is a way to think of it as one reason to fail. Unit tests are great, but if they don't give you any information when they fail, they're terrible. Don't bother. So you need a unit test that only pretty much has one reason to fail. Well, there's some leeway within reason, but when the test breaks, you want it to be because this one teeny piece of functionality isn't working properly. You also would like your unit tests to be fast. You do these right, you're going to be running them a lot. And not only you're going to have machines running them as well. You should be running these all the time while you're developing to make sure that you're not breaking something else. If you're doing test-driven development, then you run it all the time. You make changes to your code and run your tests again to make sure that your tests are, until your tests are passing. Along with that, they should be automatable. Like I said, you're going to want machines to be running these things. It's going to be part of a robust suite of tests that should get run on your code a lot, often. And of course, the informative. Again, if your test doesn't tell you anything when it fails, anything reasonable, don't bother. Do something else. So when I went looking at tSQLt, it does all of these things for us. The order independent and isolated is very cool. Each test runs inside of an explicit transaction, which is rolled back. So the database will be left alone when you're done, even if your test, as we've seen, is truncating tables. It's not going to actually truncate the table, which is very cool. One of the things that I fell in love with tSQLt, just as a side note, is one of the things I mentioned earlier. How do you record the results of your tests? If you're going to roll back the transaction, how do you keep in mind what those tests, what the results of those tests are, so that they can be reported at the end? When I saw how tSQLt does it, I was over the moon. I was so happy that this guy had figured out how to do this little trick. If you think you know how to do it, I want to hear about it at the end. If you've got a guess, and if you want to know, I'll tell you how they do it, because I think it's a pretty cool trick. Another thing, the tests are atomic. Part of the way tSQLt gets away with this is that it uses some really amazing dependency isolation features where you can say, look, I don't want to look at this other table. I don't want to use this function. I don't want to use this stored procedure. That's not part of this test. I have other tests for that functionality. My test just is this one little piece. Forget all this other stuff. tSQLt gives you the power to do that. It's really fantastic. It is also very fast. It is mostly native SQL. So the framework itself, you can read the code and see exactly what it's doing. There is one CLR. So there's an assembly that you have to run. And if anybody freaks out because you're thinking about Azure and Azure doesn't let you do assemblies, Azure has actually green-lighted this assembly. My shop, my team at university is 100% Azure. We don't have any databases that are not Azure SQL. So we're not using managed instance. We're not using anything on-prem. It's all SQL Azure, and the assembly works just fine. We've got thousands of unit tests. They take about 2 minutes to run out in the cloud. It's really pretty cool. Automatable, sure. The tests are in fact stored procedures, so if you can automate running a stored procedure, you can automate running your test suite. And the way that you execute the test is also through stored procedure. The most important, the informative, that's going to be up to you. And I'm hopefully going to give you some tools to help your tests be informative, make sense, and be useful for you. And this is not going to be the regular, you should be doing unit test presentations. I've seen a few of those. And one of the things that I thought would be interesting to see in a presentation is sort of the pull back the curtain and show you behind the scenes what is happening with the framework, why this stuff works, how powerful it is, and let you guys figure out the creative sort of uses that you can do with it. So I'm not just going to show you some of my favorite pieces. I'm going to show you how they work, the nuances to them, so you can use them in a creative way. So some of the things about tSQLt that are great, it is free. It's open. I don't think it's open source. It's free. You can look at what exactly is there. I think that if you wanted to, you could change it, but don't expect to check it in and be part of the original stuff. I actually tried that once. tSQLt does not have much support for like cross-table link servers, and I modified the code because I thought I had a great way to do some link server stuff. And I wrote to Sebastian, the main developer guy, and he said, "That's great. Where are your unit tests for that?" Because he built tSQLt entirely test-driven, and so I was really deflated. But still, you can modify it if you want. It does have support from other products. In fact, Redgate supports tSQLt. There is a plugin you can buy for SSMS, which will help you with your unit tests, help you build them, and help you run them with a nice GUI to look at the output. Another one that I've used in the past is JetBrains, their TeamCity product for test running. They have a plugin that makes the tSQLt tests first-class test citizens. They look just like all the other tests that you can run. I was really excited to see that happen. So often SQL developers and SQL code is treated as special code. It's different from all the other code. The more we can reduce that perception, the better. Also, tSQLt, you can run the individual tests that you're working on. You can run all of the tests inside of a test class, or you can run all the tests in the entire suite. Another really great feature about tSQLt is this setup that it has. A lot of times when you're writing tests, you want the same assemble conditions for a whole group of tests. You're going to write the same code over and over and over again. You don't have to. You can have this setup procedure, which will run inside of the transaction before each test inside of the test class. I have an example of that I'll show a little bit later. Part of what tSQLt does, this is interesting, part of the anatomy of tSQLt, the tests that you are going to write are stored procedures themselves. So if you can write a stored procedure, you can write a tSQLt test. The test class is actually the schema that stored procedure belongs to. What we've done for a naming convention is our test classes are the actual names of the things that we want to test. So if we have a stored procedure, the test class will be the name of that procedure, and then the tests are actually, the way that you identify it as a test is with a naming convention. So all tSQLt tests begin with the word test, and then they can either have a space or an underscore. I've heard somebody say that they've done no spaces at all, just as long as it has TEST as the leftmost 4 characters, it will work. I haven't tried that. I like the underscores, so you can double click on them and you don't have to use the braces. And that's also true, the naming convention is true for the setup procedure as well. So if you have your test class is a schema and you create a stored procedure that's just called setup, that is your setup procedure. And any stored procedure in that test class, which is a schema, that begins with the word test, that is a test. Initially, I did not like that it was a naming convention. I thought that felt a little hacky, but the more that I use it, the more I realize it's a very simple solution. And simple is a great thing to strive for. Simple is nice. I will gush about tSQLt. I absolutely adore it, but I also recognize that it is not perfect. It has some shortcomings. For example, the framework that you're going to use to run these tests has got to be installed on the same database that you want to test. This is part of the reason why it's important to have your database in source control and to be able to build one. You will want to build a database from your source control that is not your production, not your users looking at database. Deploy your test to it and run it to make sure that it's working properly. And you're going to want to do that a lot. It also is not good for link servers. I've seen people try to build just a test database and build their tests in that database and link to the database they want to test. That is madness. It is not going to work for you. It's not designed to work that way, and you will encounter all kinds of horrible problems. Yeah, don't do it. Another shortcoming is that, as I said, because these tests run inside of transactions themselves, if you have any code that explicitly has begin and rollback conditions, if you execute that rollback transaction, it will break your test. As you may know, you can begin 10 transactions, and as soon as you hit that first rollback, all 10 transactions roll back. You don't get to just go back one level. There are kludgy ways, kind of hacky ways to get around that. I've seen where inside of your test you can do if tran count is greater than or is equal to 0, then begin a new transaction and then it completes. It works. I don't like it. I think it's icky, but I don't know of a better solution for it. And having a decent test that runs is probably better than having not having the test because you don't like the syntax. Another issue, I've seen a lot of code that uses system tables, sysobjects, systables, sysviews, and one of the dependency isolation tools that we have is this fake table. It will not work on it won't work on system tables. It's designed specifically not to do that because, well, I'll show you behind the scenes what it does is this rename, which you're not allowed to do. There is also a way around that, but it is more of a programming design where instead of using the actual system table, you would create, say, a view that is just a select from the system table, and then you would use that in your programs, and you can fake that view instead of the actual system table. It's almost, if you're familiar with Uncle Bob Martin's solid principles, it's almost like the interface in solid where you'd code to an interface instead of the actual table. All right, so we're going to have some demos. I'm going to show you how to install tSQLt. It's really easy. It's just one big file. It's plain text. You can put it on the machine and run it. You do have to enable the CLR. We will build a couple of tests that won't be that exciting, but I'll show you what they look like and what happens behind the scenes. We will run some asserts. Just two asserts. The assert equals, it actually is one I don't use that often because assert equals just says my expected value is equal to my actual value. And I usually think in record sets. And so I'm more interested in the next one, which is the assert equals table, which is crazy powerful and cool, where you can look at an entire record set. This record set contains the same values as this other record set. Some of the dependency isolation, this is the true power of tSQLt, the fact that you can isolate just what you want to test. We'll talk about fake table, how incredibly cool and powerful that is, the fake function and the spy procedure. And we will briefly talk about the setup procedure, which is the bit of code that will run before each individual test. Let us go to some tests or some demonstrations. All right, there's my my old dog new trick. Fun. So before you install tSQLt, you have to configure it for CLR. And this CLR strict security, I think that was something that they started, they stopped. I've read bad things about it, but I do know that for my version of SQL Server, I did need to enable it. These steps aren't necessary for Azure databases. You don't have to do this. But all you have to do is sp configure, reconfigure, and you're done. Now it's set to handle that, that one assembly. This is the great big file that you get if you download from tSQLt. It's got the licensing information, and you can probably see it is a very big file based on the size of the bar. You can go through it and read it if you want, but it's really not for reading, it's for executing. And when it's done, it tells you, it thanks you. No, tSQLt, thank you for being around for us. All right. Now, as I had mentioned, a test is a stored procedure. That stored procedure belongs to a schema. That schema is your test class. This makes it really easy to organize all of my tests inside of a test class. All the tests that belong to the same schema belong in a test class. And when you run these tests, and you always need to run them inside of the tSQLt framework, the framework knows if it's a test or not, if it knows if it's a test class. And I'll show you how it knows that. You build a new test class with this great new test class stored procedure that's in the tSQLt schema. I'm just going to create a new test class called demo. Really very boring to see that happen. But behind the scenes, what is going on? I will show you what it looks like. I've got a query that selects from the schemas table and the extended properties table. If you don't know about extended properties, that's something that SQL is specific to SQL Server that they added. It allows you to just add basically arbitrary metadata to almost any of your objects with different levels. What tSQLt does is it associates some metadata with a schema that it creates to basically just indicate that it is a test class. This is the extended property. Now, if you wanted to, because I have done it, you can independently create a schema, add the extended property of tSQLt.test class with a value of 1, and the framework will recognize that as a test. But that is really kind of burdensome. Just do that. It's a lot faster, a lot easier. It does what it's supposed to. Now, the unit tests are stored procedures. They belong to the schema that is the test class. So here's my schema, my demo test class. I'm going to build a test that just says test. It's a demo test. The naming convention says you have to have the word test begins it. All this is going to do is set my no count to 0 and return. That's it. Very boring. But the way that you run your tests, this is important, you always run your tests through the framework. You can use tSQLt run and give it the name of the test, including the schema, and that will run an individual test. This one is insanely boring, but you can see that it succeeded. And again, this is the trick. I want you guys to think about how we begin a transaction, run this test, roll back the transaction, and then display the results without the results being rolled back. It's fun. Here you can run all of the tests that are inside your test class by eliminating the name of the stored procedure. If you just give it the test class name, it'll run them all. I only have the one, so it's not very exciting. And then you've got the run all. This will run all of the tests in all of the test classes. Again, I've just got the one test. Not very exciting. Now, the reason why it's very important to use run or run all, you're going to be doing some pretty powerful things in your test with the faking tables and the spying procedures. This tSQLt run and run all, it's responsible for making sure that the transaction gets rolled back and it displays the results. If you don't do it inside of this, you could really severely damage your database. I have done it multiple times. I have a really bad learning curve when it comes to this. But I see this as a stored procedure and I just say, let's run that. And then I break my database and I have to rebuild it from source control. Now, as I had mentioned, if you, additional support for, did I mention this? That the results of your tests, they come out to this to the text down to this little console window down here. That's the default location. But if you need them to be consumed by something else, you can, after you run the test, you can run this tSQLt XML result formatter, and it will generate XML for you that looks like a JUnit test. So if you have anything that reads JUnit test results, you can have it read tSQLt test results as well. I don't remember mentioning that. I hope I mentioned that. Makes me think I missed part of my slide. All right. So here is a demo to talk about the assert equals. Again, this is one that I don't use very often. It just compares two values. I'm going to create a stored procedure, which is my test. It begins with the word test. I am going to declare an expected integer and set it to 100, and an actual integer, set it to 200, and then I'm going to use the great tSQLt assert equals to say, is my expected equal to my actual? Now, in unit test writing, this is kind of important as well. I had a C# developer really had to pound this home for me because I was not getting it. You always do expected first, and then actual after. Expected on the left, actual on the right. These are named parameters. In theory, I could switch them. I could put them in whatever order I want. But it's good form, and you'll see in the results later on, you'll see why it's important to do this. It's not just the standard, but it's used all over the place. So as you can tell, this test is going to fail, or it better, because 100 and 200 are not equal. And that's what I am asserting, that they are in fact equal. So when I run this, here I'm going to run just all the tests in the test class. We already have a test. This is our second test. So when this runs, it should run 2 tests. You can see that it did. There's the one that we built first, and it's a success. This is the one that we just built. It does, in fact, say a failure. You got a nice little red summary here. And at the top, it tells you what happened. We expected 100, but we got 200. Nice. Thank you. This is useful if you're checking like return parameters and things like that. I guess that works out fine. Now, any SQL developer worth their salt has been bitten by nulls, because as you know, null is not equal to null. And if you ask for them to be equal, SQL Server will tell you no, and you should rethink some things about your life. Well, sometimes you want to know, hey, I expected a null and I actually got a null back. I know they're not the same null, but could you please let me know if they're both null? And so here I'm saying, look, I expect a null and I actually got a null. Please don't fail. And it doesn't. It knows. All right, we're going to say that even though those aren't the same null, we're going to say that they're equal. That's pretty nice. You don't have to do any special null trapping around those values. All right, assert equals table. This is one of my favorites. So assert equal table, if you're dealing with more than just one value, if you're dealing with a record set of information, this is your buddy, this is your pal. What I'm going to do for this demonstration, I will create an actual table in the DBO schema called test table. I'm going to give it non-nullable columns, an auto incrementer called ID, a string, and a date value. Nice and simple, really just ridiculous. Now, I want to show you what the assert equals table looks like. The first part in our arrange, this is where we package up everything we need for our test to run. I'm going to insert into that table. Now, because these are non-nullable, I have to include them both, and I'm of course not going to touch my auto incrementer. So I just put in a string value and a date value. Now, I'm going to create an expected table. This is going to be my actual table, and in my test, I'm going to compare, does this actual table contain the same values as my expected table? But here's what I want to show. My expected table has only one column, just the my string. It doesn't have the my date. And you'll also notice that the way that I'm building this is not necessary, but years of writing tests, I do it this way now. I am creating my table with a select into, instead of explicitly declaring the structure of the table and then just doing an insert statement. Part of the reason I do this is a very simple table, but part of the reason I do this is if ever this table changes form, if ever I'm doing more than just select a distinct column, I would have to go in and change this test because now my expected table has a different form than my actual test, my actual table. If I do it this way, I'm guaranteed this data type is going to be this data type. I know that there's strings, but sometimes you would do like a select star to build your expected table if you want to compare the entire table. That works out. And here's my assert. I don't really have an act in this because I'm just creating an expected table. So here I've inserted my string value into my expected table, and then I'm going to check, is my expected table on the left the same as my actual table, which is the actual table on the right? It's not checking, are they the same table? It's asking, do they contain the same data? And according to the test, they do. Now, even though I was only comparing one column, I wasn't comparing both columns on the table, but it's letting me know the one column that it has in common, those have the same values. As you can see, also, just to show, it did run in a transaction. My table is still empty, and that expected table, which I selected into, it doesn't exist. It's because it's all transactions, right? I left the database alone when I'm all finished with it. It's pretty cool. More assert equals table, because there's just too much about it. I need to show you what a failure looks like. Again, your tests have to be informative. So if something goes wrong, you need to be able to look at the results and say, what is wrong with this? Assert equals table is so cool the way that it handles this. Now, this is a very similar test. I'm going to insert, again, the string and the date, but my string now is a shared row. And the reason this is a shared row, for the sake of this demonstration, to show you what is happening with assert equals table, I'm going to have one row that is on both my expected and my actual. I'm going to have one row that's just expected and not actual, and one row that's just actual and not expected. And then the results, the test will fail, and it will show you why it failed. So here's my expected table. I got to get rid of my squigglies, sorry. All right, so now I'm going to select that string value back into my expected table, just like we did before, but now I'm going to create a distinct row that is only on my expected table, which is creatively named only unexpected, and then one that's only on the actual table. And here's the same assert. And I know that this assert is going to fail. It's designed to fail because I want to show you what the results of a failed assert equals table looks like. Look at how cool this is. So it shows you, again, on the left, this was a row that was unexpected. In the middle with the equal sign, this is the rows that were the same. And then on the right, this is what was actual. That's a really cool feature that it fails and it tells you, hey, my record sets are different. I think the row at the top says unexpected or missing result rows. And it shows you what they are. That's really useful, very informative. Now, so far, when I've been inserting into this table, because the two columns are not nullable, I've been inserting the string and the date, but I've only been evaluating the string. For the sake of my test, we'll say I don't care about the date column, I only care about the string column. So for what I'm going to do here is I'm going to try to insert just the string value and do the same expected table and the same comparison that we've done before. And we'll see how tSQLt handles something like this. And it fails because you can't insert a null into my date, and I'm trying to do that. So as you might have expected, as you might have guessed, you can't do it. Which brings us to our first part of the dependency isolation, fake table. Fake table is insanely cool. This thing is so powerful, it's difficult for me to put into words. I will tell you what it is doing behind the scenes, and I will show you what that looks like. This is the same code that we just had with one addition. Before I do the insert of just the string value, I'm going to execute tSQLt fake table, give it the parameter of the table name, which is the table that I want to be faked. And what this does, tSQLt fake table, it takes your actual table, this parameter, and it renames it. And if you've ever renamed anything in SQL Server, you know that there's a warning you cannot suppress. It screams at you that you're going to break your code because things reference this table. And now those things are pointing to something that doesn't exist anymore. Part of what the CLR in the tSQLt framework does is suppress that warning. Because what it's going to do is it's going to rename this table to something distinct and not tell you that it's done it. And then it's going to look at the metadata of that renamed table, and it's going to create a new table with the original name. And the new table will have the same columns, with the same name, with the same data type, and that's about where it ends. All of the columns will be nullable. There will be no constraints, no defaults, no foreign key constraints, no indices. All of that stuff stays with the actual table, which has been renamed. So all your data is still there, everything's still there, but now you've got a pure copy of the table where my date column is no longer not nullable. All these columns are nullable. So I can insert just the string value if that's the only value that I care about. And now when I run my test, it works. We get a success. Now keep in mind, because this is a transaction, if I try to run this independently, it's going to fail. I can't insert that. But inside of the test, after I've faked the table, it works just fine. Now, this becomes more apparently useful if you have parent-child relationships. Like I said, those things stick with the actual table, which has been renamed. So here's, again, a very simple set. I have a child table, a parent table. The parent table just has a name and an ID, which is a primary key. The child table has got the parent ID as a foreign key and some information about the child. This is just crazy simple. I create the actual foreign key constraint, right? And that's a non-nullable column. If you have a parent ID, it has to exist on the parent table. And then I just throw in a default constraint for get date on the date column. Not because I'm going to do anything with it, but because I want to show you how it disappears when you fake the table. So if we just do SP help on this child table now, we should see, let's move this up a little, and we should see some of the things that are concerning for us when we want to write a unit test. First of all, on this child table, all of these columns are not nullable, which means that if we want to add data to this table, we have to add every single column. But this parent ID is a foreign key, which you can see down here, which means we have to insert a row into the parent table as well. And that's if you want just the arrange part of your unit test, right? The test needs to bring with it what it's going to test. You'd have to create the parent row and the child row, and then roll all that back. Well, with a fake table, the only thing I'm going to do in this test, again, this isn't to show you a valid test. This is to show you behind the scenes what is going on. It's the same SP help on the same demo table, the child table, after we have faked it. So that's all that this test is going to do, is show you what that table looks like after we say fake table. This is so cool. It's the same name. It's still demo child table. It still has all the columns. They are still the same data type. That all works, but nullable. All of them, yes. No identity, no indexes, no foreign key constraints, none of those. They're all gone. So this table is a clean slate. You can put into it whatever you need just for that test. As you can tell, this is just to show you that it is, in fact, inside of the transaction. All of that stuff comes back outside of the test. I like to pause here for a moment to just think about the power of this fake table. I'm using very simple examples, but I've seen databases where tables are hundreds of columns wide and at least half of them are foreign keys and nothing is nullable, and you've got a ton of constraints and calculated columns and all sorts of things. And there's no reason, I mean, I understand why you don't want to write a test for that. That is a daunting task. Some of these tables have parents, grandparents, great-grandparents. That's terrifying to think about trying to write that amount of data. You don't have to. tSQLt gives you the power to just say, look, there needs to be data on this great-great-grandchild table that I need to evaluate. Just look at that. I don't need to look at all the other stuff. For this unit of work, there needs to be this row on this table, and that's all I want to look at. And tSQLt lets you do that. It's awesome. Now, sometimes you do want the constraints, and sometimes you want I don't know about the indexes, but sometimes you want the constraints, sometimes you want the defaults. tSQLt has got you covered there. It has these optional parameters that you can pass in for fake table. This is essentially the same test that we did before. Excuse me. Great way to get your attention these days is to cough. I'm going to do the same fake table, but this time I'm going to tell it that I would like to keep the identity and I would like to keep the defaults. And then I'm also going to tell it, you have this great tSQLt apply constraint, which says, hey, I just faked this table. I want the foreign key constraint to be included on it as well. So this is roughly the same, but now I'm applying the defaults and the identity, and I'm going to do the same SP help just to show you what tSQLt does behind the scenes when you tell it to fake a table and you still want the constraints. I should have let that finish, sorry. All right, so this is now the faked table. You can see it has the same name. It looks pretty much the same. The nullable is still there because I didn't say, I'm not sure you can do that. But it has an identity. It has got a default value, which you can see it has a new name, a new interesting name that the database came up with, but it also has the foreign key. So if you have a test where you needed to test something like that, for example, in some of my code, we would use an auto incrementer as a tiebreaker if we have data that we're selecting a record set that is not distinct enough to be sorted properly every time. We could use it as a tiebreaker. You might need a value in that identity column, and it normally wouldn't be there, but you can tell tSQLt to go ahead and put it in there. Now, the way that we code, we have a lot of synonyms that we will use. And if you're not familiar with synonyms, I'll just briefly tell you. Synonyms are another really cool SQL Server thing that they came up with. I'm not sure if it's distinct to SQL Server, but it's basically just like a symbolic pointer. It can point to, I think, just about any part of the database. I'm not sure what it can't be. Your synonym can be a table, a stored procedure, a function, a view, and they look just like this. I'm just going to say, hey, if I have a synonym called synonym child table, then drop it, and then I want you to create a synonym called synonym child table for my actual table. And what the synonym does when it's built is you can use it pretty much as the, I gotta get rid of my squigglies, sorry. Can't stand the IntelliSense squigglies. What you can do is now you can reference this synonym instead of the actual table. And a lot of times if you have code, for example, if I have a stored procedure that is using a synonym for a table instead of the actual table, I don't want to fake the table. The code that I'm testing doesn't use the table, it uses the synonym. This is really important. You want to fake the things that are actually being used inside of your tests. If it's a view, don't fake the things that feed the view. If the stored procedure uses a view, fake that view and use that view. Don't use the source code. That's not a good test. It's not a valid test. You're testing something that isn't actually being utilized. Don't write those tests. All right, so here I've got my synonym, my child table. I can tell you that if you just do a select from it, there's no data on it, but it looks like a table if you do a select on it. But that's about the only place it looks like a table. If you look at what it is, the synchild table on sysobjects, it is not a table. It says it's a synonym. If you ask for SP help, like we've been doing on the child table, it just says it's a synonym. Doesn't show any help on it. Or if you join up the columns table, the sys columns table with the objects table based on the name, on the object ID, yeah, there's no columns. So you can insert into it as if it were a table. You can select out of it as if it were a table. You can delete. You can do all that stuff as if it were a table, but it's not a table. Oh wow, I just did way too much. Sorry, hit the wrong button. So what I'm going to show you is that tSQLt understands, it can understand synonyms. So here I'm going to use the same fake table on the child table synonym, not the actual table anymore. And then I'm going to insert into that synonym, and then we will select from the synonym. And this is all without telling anything about telling tSQLt that synonym is actually a table. It just knows. It's smart enough to understand that was, in fact, it needed to be treated like a table. So that's pretty cool. If you use synonyms in your programming, that is not a reason not to use unit tests. And as I said, it works with views as well, which is really cool. So here is it doesn't have a specific like fake view. It use fake table for it. So here I'm creating a view that is my child table view, and you'll notice this DCT is the child table, and it calls one column from a parent table, which is just the parent name. That's the only thing that is distinct on this record set to the parent. The parent ID is on the child table, parent name's on the parent table. Joins up on the parent ID. It's a really simple view that just selects from two different tables. You can use that inside of you can use fake table on the view as well. Here I'm going to show you. We're going to fake the view. We're going to insert some data just on the child columns, child ID, child name, and some date. And then we're going to select from that view and show you that that actually worked. So there's the test. And when we run the test, you can see, hey, look at that. So the child ID is something that I declared. I said, make that be -1. I did not say anything for parent ID or parent name. Child name and some date, those were values that I provided. So I was able to fake the view, throw this data in. If I have some test that needs there to be certain data in a view, you use this. You can set the values to be inside of the view itself. The rest of your test can say, when this view contains this data and I perform these actions, I get these results. Now, here's something that's fun to think about. What if I try to put something into the parent table? So the parent name is distinct to the parent table. And here I'm going to try to insert into it. I'm going to try to insert a parent ID as well. And we will try to run this test to see if tSQLt as well. Look at that. We get an error. It says that we can't update it because it references the modification affects multiple tables, and it's right. It's absolutely right. We can't do this, and that sucks. But something that you should notice is that that's a compile time error. I can't even build this stored procedure, much less run it. I can't build it. So the problem that I have to fix here, the challenge that I have, is to get this stored procedure to build. If I can get this stored procedure to build, I know that it'll work just fine. So one of the ways that I do this, because I encounter this all the time, I will still fake the view, just as we had done before. And the reason you want to fake this view is because you want all of the columns to be nullable. You don't want any constraints on it, all that sort of stuff. What I will do, if I know that I need to have values in this view for my test to work, I will create a separate table. I usually call it just source table. I will put it in the same schema as my test class. And I will create this source table by selecting top no rows, 0 rows, for just the columns I care about. And I will put it in my source table, and I will select those from the view that I've just faked. The reason you need to fake this first is if there are any constraints or anything, nullability on this view, that will get carried over into your source table, and you probably don't want that. Fake the table first, and then create your source table. Then you can put just the data you care about into the source table. You're not putting it into the view anymore. Now I don't like dynamic SQL. It feels hacky, but it certainly gets it to work. I can execute some dynamic SQL to say insert into the actual DBO child view, the view that I've faked. I can say put that data in there, selecting from my source table. Now I've only put in 1 row here. If I put in 100 rows or 1,000 rows, this statement's still the same. I'm still just inserting from the source table. Now, because this is dynamic SQL, it is not evaluated at compile time. It is only evaluated at runtime. Because of that, we are able to build the stored procedure. We can now compile the stored procedure. When we run it, it does what we expected. Now we have our child ID, we have our parent ID, and our parent name. We did not put in any of those values. So again, to me, it feels a little bit hacky. It's not too bad. But I would much rather have a test that checks these things than not have a test, because I don't like the semantics of something. I think it's more valuable to have the test. Fake function. Okay, we've talked, there might be a little bit more to fake table. There probably is if you check the documentation. That's about the extent of what I use it for. And I find it just crazy useful, just that. Fake function. This is more dependency isolation. This is great. If you have a stored procedure that executes a few functions, gets a few values back from these functions, and then does some stuff with it. The unit of work I want you to write a test for has nothing to do with those functions. I want you to just test that unit of work. So we don't want to actually execute those functions. They are not part of this test. You should have tests for those functions, sure, but the one piece of code that I want you to test right now has nothing to do with those functions. We want to test some values that have come back from them, but we need those values to be explicit. So we can't rely that those functions are doing the right thing. So what you can do is you can use this great fake function. Now there are some requirements for fake function. You need to actually build a function to replace the function that is going to be that is actually used in your code. That function that you are going to create has to have the same signature. It has to have the same inputs. It has to have the same outputs. So if it's a scalar value function that returns a float, then your fake function should be a scalar value function that returns a float. I'll show you what that looks like. Here is a scalar value function that returns a float. It's a very silly one because it just does a square root of an integer value that is passed in. You should probably just use the square root, but you know, whatever. And I'm going to show you that this actually works, right? If I select the value of my function from 9, it returns 3. I'm not going to zoom in. You guys just have to trust me. If I select 25 from square root, we get 5. And if I select -1, we get an error because you shouldn't be trying to find the square root of a negative number. Now, if I am using this function anywhere in my code, and I don't actually want to test that function, I just need to say, look, when I call this function, I expect to get back a number. And we'll just say I expect it to get a 3 back. I don't want to actually execute that function. So what I'm going to do here in my test, this is one of the ways that you can do it. You can create the function through dynamic SQL in the test itself, right? So I'm just going to execute this create my square root function, and it's always just going to return a 3. Now, when this test runs, it'll create the function. Down here is where you say, I want to fake the function. Here's the real function. You notice it's the DBO square root, and I'm going to replace it with my demo square root. What tSQLt does behind the scenes is it basically swaps those functions out and says, don't use the real square root function. Use this fake one we've just created. So in this test, I'm going to show you how this works. We're still doing square root of 9, square root of 25, and square root of -1, but this is after we have faked the function to say, I don't care what your input is. I need you to return a 3. So when we do the union all against this, hey, we just get the 3s back. Now, I'm like, you probably are figuring out I'm not a big fan of dynamic SQL. So another way that you can do it, oh, I also needed to show you that the original function is unchanged, right? It gets put back. So we get the real values from the square root function when the test is done. Again, we're not going to change the database. Also, I should show you that the square root function that we created, the demo square root function, it doesn't exist. There's my red squiggly that I hate, and that's not a real, it's not a real thing because it was created and rolled back. So another way that you can do it is, let's build a different function for you. So this is just a quotient function. It's going to take a numerator and a denominator, and it's going to divide the numerator by the denominator and return that for you. And that is a real function. One of the things that you can do in your test code is you can create an actual object to replace your demo, to replace your faked function. Now, this is where that naming convention comes in handy again. Like I said, I didn't like it at first, but it seems a little bit better. Here I'm using my test class as my schema, and I'm giving it the same name as the function that I want to replace. You don't have to. The rules are it has to have the same signature. It's got to have the same input types and the same output type. But I'm creating the actual code. This would be part of my code base for my tests, just my tests. Would never hit production. You never want your test to hit production. So this would get checked in with the test itself, and it gets built along with all the other stuff. And then it's just a real, I mean, on my test database, it's a real function that gets built when the tests get deployed. And here you can see the real quotient function. It works just fine. Maybe if I go to text-based, it'll be a little bit easier to see for now. So there's, again, 10 divided by 5 is 2, 10 divided by 2 is 5, and 10 divided by 0, you should rethink your life. Stop doing that. So here, now that I've got my actualized, my actual fake function that I just want to use for my test, I can replace it this way. I can just say, hey, take my DBO function and replace it with my fake function, my test function. And now I don't have that dynamic SQL in there. It's a little bit cleaner. And when I run it, I get the results back that I expected. This just says success. Wait, why does that just say success? I expected to see a select. Show this to me. Oh, there's the values. They're up top. I switched to text. That was the problem. The other thing that's nice about that is that if you create the function and you make it like an actual file, an actual object that gets built, if you have another test, a separate test, it can use the same fake function, and then you don't have to rebuild it. You don't have to use the dynamic SQL to rebuild it or anything like that. And if you want to get really clever and really creative, you could have a fake function that maybe reads values from a table. And you could have that table get created, and inside your test, you could write values to that table that you expect to come back, that you need to come back. And then when it runs the fake function, it just reads those values from the table. And that way, inside of your test, you could have it populate what values you expect the functions to come back for. A little bit more involved than just the fake table. All right, so here is a table value function because, again, I think in data sets. This table value function does some reading from the sys_all_objects table, and I just wanted to show me, hey, give me the schema name, and if I've passed in a type, then show me all the objects for that type as well. Make sure we really built this. There's a real function, it works. As they show me from the system schema, anything that's a stored procedure. And hey, look at that. It returns values, cool. And it does it for X and for DBO user tables and tSQLt everything, because I did not pass in an object, a type. So if I have a function like this, I can create a fake function of it that just says, look, whatever schema name you give me, I'm going to return that. For the object name, I'm just going to return the string object name. And if you give me a type, I will return it. Otherwise, I'm going to return the word type. So that's my fake function. It's not nearly as fun. If you run that, it just returns the schema, object name, and whatever you pass in for type. Excuse me. Right, on we go. So here I'm going to use my fake function. I'm going to use the tSQLt fake function isolation dependency and say anywhere you see this TVF tables, replace it with the demo TVF tables, and then I'm going to just to show you what happens when I select tSQLt with no options. What that test does now that I faked the function is it just returns the schema that I passed in, the word object name, and the word type because I didn't pass in a type. Cool? Cool. It's very cool. All right. So we've talked about faking the tables so you can get the table to look the way that you want. We've talked about faking functions so that you can make the functions look the way that you want. We've got SPY procedure. A lot of times stored procedures will call sub procedures, smaller stored procedures. And again, you don't always want to test those sub procedures inside of the context of your test. They should have their own tests, absolutely. But if you are testing the functionality that does something with these other procedures output, don't test those procedures inside of the unit test for this functionality. Keep the unit of work very, very small. What are the requirements for SPY procedure? Similar to a fake function. It should have the same signature, same input, and ideally it should have the same output. SPY procedure does a couple of cool things. So it's a little bit different. If you just say SPY procedure and give it a procedure name, you don't have to tell it anything else. All that tSQLt will do at that point is make sure that when it encounters inside of the test, when it encounters a call to that stored procedure, it will not call the stored procedure. But what it does do is it writes to a table that it creates for the test if there were any parameters passed into the call for that stored procedure. And it will write them to that table, and you can query those later. So you might have a test that says, I need to know that when I give you this value, you call this stored procedure with this parameter. tSQLt lets you do that. It won't actually call the procedure, but it will say you wanted to call it and you wanted to give it this parameter, which is very cool. We'll show you what that looks like in a little bit. Here I'm going to show you, I'm going to build two quick stored procedures, and the second procedure is going to call this first one. This is our parent and child tables again. For inserting into the parent, we're going to take a parent name as an input, and we are going to return the parent ID, which is our auto incrementer, as an output. This is very simple to do. We insert, we select the scope identity, and we are done. Inside of a transaction, I'll show you that it works. I'm going to insert the demo parent with a parent name, and we'll look at the output, and then we'll roll back the transaction. Right on. There's our inserted ID. We inserted 1, and we inserted parent name. Very cool, the stored procedure works. Now, for the sake of my application, I'm not really going to call the parent independently. I'm going to create the child, and the child, when I call this insert demo child, I'm going to want to know, I'm going to pass in what the parent name is, and the child name, and then the some date value that we put in there. And I'm going to expect this stored procedure to call that other procedure to create the parent for me first, so that I can get that parent ID, which is a foreign key, and I can include it on the table. So first thing I'm going to do is declare my parent ID. I'm going to create the parent row and get the parent ID using that sub procedure. And now after I've got that, I can create the child row. Hey, my dogs let me know somebody's here. Now, did I actually build these procedures? I think I built these. Oh, that was a check to see that it works. Oh, my poor puppy dog. I don't know if you can hear him. He's a Visenji, so they do that. All right, so there's my stored procedure that creates the demo child, and it is going to call this insert demo parent. I'm going to show you that that procedure works as well, also inside of a transaction. So I have created, you can see here, my parent ID. You notice that the auto incrementer is now at 2. Rollback transaction does not reset your auto incrementer. The first one was 1. This one is 2, even though there's no other rows on the table. And here's my child rows. Yay, it works. It creates the parent, and then it creates the child row with the appropriate parent ID. Outstanding. Now, inside of this test, I'm going to test that my insert demo child inserts a row on the demo child table. What I am not going to test is that the parent row was created. I'm not going to test anything about that other stored procedure. I just want to test that when I call this, I'm adding the data to my child table. So here in my arrange, what I'm going to bring with me, I declared my parent, child, and some date. These are the values I'm going to expect on the child table. I'm going to fake the child table. This has a lot of benefits. It cleans the table up and makes sure that there are no foreign key dependencies I have to worry about. For this table, we know that it's empty, but depending on your database, there might be lots of rows on the table that you need to fake. And I don't want to filter through those. I need the table to be clean. I'm going to put on it just what I expect and read that back. And that's one of the things that this does. And here is my spy procedure. And I give it the procedure name that I want spied. And again, if you don't tell it anything else, all this is going to do is make sure that this stored procedure does not actually execute, and it will record in the table for the duration of the test that you called it and what parameters were passed in. I'm not looking at that just yet. My expected table, this is what I expect to be on the child table. The child name and some date from my expected table. And then I'm going to, for my act, I'm going to actually call, I'm exercising the feature. I'm exercising my insert child table with my expected parameters that I've declared above. Now, this is not something you would put in a test, but I'm going to put it in here so I can show you again what's happening behind the scenes. I'm going to select from my parent table, my child table, and my expected table to show you inside the test what this looks like. And here's my assert, which should return true. I'm expecting it to call and actually insert the child name and the date into the table. Let's build this test. And when we run it, we should see the output of those select statements. Okay, cool. You can see the parent table, nothing happened. We didn't insert anything into the parent table. Spy procedure prevented that from happening. On the child table, we did insert the child name and the some date like we expected. This is our expected table. So as I expected, as I desired, we didn't actually call the insert parent table, stored procedure. We didn't call it, which is good. Now, if you're interested in that parent ID, again, you might need that value to be something. You can set up and specifically say, I need there to be a value, and this is the value that I want it to be. Spy procedure has this really great extra thing, command to execute. This is an nvar charmax where you can set up some dynamic SQL that it will execute instead of the stored procedure. So one of the things our insert parent procedure did is it assigned a scope identity value to the return parameter of parent ID. We are going to do that, but we are going to set it specifically to whatever this value is. Right now it's set to -1. So whatever our expected parent ID is, inside of this command to execute, we're going to say, hey, instead of executing insert demo parent, just execute this command. Set the parent ID to whatever the parent ID was that was passed in. Once again, we're faking the child table. And then we are going to use the spy procedure with this new added parameter, command to execute. This is so cool. we aren't going to run insert demo parent. Instead, we are going to execute whatever SQL is there. And now in our expected table, we're going to include the expected parent ID. Here's our act where we actually call it the same act as before. And again, these I had them commented out because that wouldn't be in your actual test. This is just for the sake of showing you what's going on. The assert equals table, I expect that to be true, which would be not as interesting as the results to actually see in these selects. So let's run this and look at these selects. This is also very cool. Again, the parent table, nothing happened. We didn't call the insert parent procedure. But on the child table, we did get the parent ID that we expected, which was returned from the call. And we got our name and dates in there. And this is our expected table, and that's why the test succeeds. And the last bit about SPY procedure, as I was mentioning, it records for you what the parameters are that were called. That's what this test is going to show us. We are going to, it looks basically the same. We still have the same command to execute. The thing that's different about this is our expected table. For this test, I want to show that we actually did call insert demo parent. We did make a call to that, and we passed into that procedure the parent name that we expected up here. Right, so when we act and we say insert child demo, this parent name should be an input parameter to this insert demo parent. And I want to test that we actually did that. Now, this is the table. I said that it creates a table to store those results inside of the test itself. That test is always going, or that table is always going to be named, first of all, the name of the procedure itself with an underscore and SPY procedure. This gets built whether you use it or not. It's just part of the way that the framework works. But it will create this table, and the columns look like the parameters, and the values inside of those columns are the values of the parameters that were passed in. So for my assert equals table, I'm going to say, look, my expected table is this expected. I expected to see the parent name. That's what I want to check. Did you call the parent name? Is that inside of this SPY procedure log table? And if it is, that tells us that my procedure tried to call this stored procedure and passed in that parameter. And here you can see it. So this is that SPY procedure table. It has its own identity that it includes, but this is the name of the parameter, parent name, and it tells me this is the value that was there. Parent ID is a return parameter, so it gets included as well because it's a parameter, but it shows null. So that's a way that you can write a test that says, I don't want you to actually run the stored procedure, but I want to know that you tried and that you passed in these parameters when you tried to, because that's a good valid test. All right, one of the things that I mentioned was the setup. So in the arrange section of your unit test, you might find yourself writing the same code over and over and over again. If you just create a stored procedure named setup, that is the code that will run before each individual test. I'm going to create a new test class that's called insert procedures. And now that that's built, I should be able to get rid of my squigglies because of the IntelliSense. Right. So here in this new test class, insert procedures, I'm creating a stored procedure called setup. This naming convention says this is going to be run before every test. And it's going to tell you that with the select hello from setup. Pretty boring, but I'm just illustrating how it works and what it does. Here's test number 1 in the same test class. It just says hello from test 1, hello from test 2, and hello from test 3. Now, because these all belong to that same test class as our setup, if you run them individually, and this would probably be better as text, I guess. If you run them individually, you will see hello from setup and then hello from test 1. That's true for test 2 as well. Hello from setup, hello from test 2, and as you would expect from test 3 as well. Hello from setup, hello from test 3. If you run the entire test class, right, so we're not running an individual test, you can see that this hello from setup is run in between each test. We get it for test 1, we get it for test 3, we get it for test 2. So it runs all the tests, and it runs the setup prior to each one. It's very cool. It's inside the same transaction. It can save you a lot of work, a lot of coding. Was that the dry principle? Don't repeat yourself. Cool, cool, cool. That's about all I have to say about setup. Really useful, pretty cool. All right, so this part of the demonstration is more, I'm not talking so much about the things that tSQLt can do for you. I've showed you most of the ones that I use over and over again. There's still a lot more there. I recommend going to the page and looking at the documentation to get started on this. It's great. These are the ones that I find crazy useful and beautiful and brilliant. I'm going to show you an example of a test for a function. Now, the purist would say that you should probably have one test for each thing that the function is supposed to do, and you could argue that for sure, but I don't think that your code will be fundamentally better if you create 8 tests that are almost exactly the same as opposed to one test that could show you 8 different results. For this test, I've created a function that's called format name. This is a fairly common request that people have. Given a first name, middle name, and last name, I want to see last name, comma, space, first name, and middle name. And that's all this function does. It just says concatenate those values together and return it to me. Now, as it turns out, my customer wants more than just this. I'm going to create a test class for my function. I'm going to get rid of my squiggly lines. I'm going to start by writing a test case that says that my format name formats the names properly. And the way that I'm going to do this is I want to just have one test that shows me that all of the possible combinations return the result that the customer wants. I'm going to start by building this test cases table, which will have a nice informative name, tells me what I'm testing, the data that I will pass into the function, first name, middle name, last name, and then what I expect the formatted result to be. So this is my test cases table. And then I'm going to populate it with all the possible combinations that I can think of, everything that the customer has said they want. If I have no null values, first name, middle, last, I expect last name, comma, space, first name, middle name. If I have a null first name, then I just want to see a comma and a space at the last name. I don't want to see 2 spaces, one for middle name. If I have only the last name, this is what I'm going to show you. So this is all of the conditions that the customer has said they want. You give, and this is all the possible combinations. So anything that I get, this is what I expect. Now, I'm going to use the act to create my actual table. And what I'm going to do is I'm going to select the test case, which has the nice informative thing. This is what I'm looking for, the data that I've passed in, and then I'm going to exercise my actual function, passing in the values from my test case table. And I'm going to call that formatted result, which is also what it was called here, because I want to compare these 2 tables. Now that I have a test case table, which was populated by hand by what I expect, and now I have an actual table that was populated by the function, I can compare the results and see if they look the same. And here I'm using my absolute favorite assert equals table to say, does my test cases table look like my actual table? Let's take a look. As you might expect, my format name function is a little wanting. It does not take very many things into consideration. So first thing it tells you is that it did in fact fail. This test, my function isn't doing what it's supposed to. In fact, out of all of those examples, the only ones that looked properly are these 2 in the middle that are equal. If I have a null middle name or no null values, then it returns everything properly. Otherwise, it fails. It shows me that this is up here, again, on the left, what I expected. Down here on the right, this is what I got actual. So the big question is, how do you fix this function? And I don't care how you fix this function. It doesn't matter. You need to make this test pass. That's all you got to do. And once you make this test pass, it's all the requirements that the customer has asked for. You are done coding. You're finished. You make this test pass, and then you move on. That's sort of a test-driven development approach. Granted, I stubbed out the function first. This is sort of the idea that the definition, the documentation for what this function is supposed to do is the actual test itself. And if that needs to change the test first. And then you go back and you change the function until the test passes. All right, one of the last things that I want to show you in my demonstration, I don't know how I'm doing for time. I don't know if I'm fast or slow on this. The last things I want to show you for the demonstration is I talked about the data contract. Stored procedures don't just set parameters or make inserts. A lot of times they return record sets, and you want to check the output of those record sets. And that is classically difficult with SQL Server. It is difficult to take a record set as output from one stored procedure and use it for input for another. You can use table variables and that kind of stuff, but it's just a freaking nightmare. So I'm going to show you a stored procedure here, which is going to return a record set. It's going to select these values, again, from our classic parent and child table, based on the input parameter of the parent ID. Those tables still don't have any data in it because everything we've done is inside of transactions. You can see it does, in fact, return a table. It's empty right now, or it returns a record set, not a table. Now, I don't know if you all have heard of this. This used to be an undocumented thing in SQL Server, and I think that they have made it official and it's documented now. It is a very handy bit. Just like it's named, this is what it does. It describes the first result set for an object, and in this case, the object is that stored procedure that I just built. And I'm going to ask for the column ordinal, the name, the system type, these other things about that stored procedure. Look at the output of this thing. This is really cool. So it tells me column number 1 is parent name of this data type, whether or not it's nullable, the length, precision, and scale. That's really useful, and that's for the entire record set that comes back from that stored procedure. I can use this to build my data contract. I'm going to do that right now. I'm going to create a new test class that is the name of the stored procedure that I want to test. I'm going to get rid of my squigglies. All right, so this is my my test to make sure that the data is returned in a correct structure. I'm going to begin by creating my expected table. Again, I'm using the same test class schema. And it's going to look just like the output of this thing. I'm going to look at the column ordinal, the name type, nullable, precision, and scale. And now what I'm going to do is I want my actual table to be the exact same as my expected table. Right now, they will both be empty. But instead of redefining this, I'm just going to use that trick again of select top 0 star into my actual table from expected. That will just essentially duplicate the table. And now I'm going to put the definition of that record set into my expected table. This again, this is the documentation. This is what I need this procedure to be. It needs to return a record set that looks like this. If it doesn't, my test is going to fail. Excuse me. And here is where I put the actual information into the actual table. It has the same format as the expected table, but I'm going to use the same select that we just had from the described first result set from that object. And it is going to take that same result set that we saw up here, and it's going to put it into my actual table, and then I'm going to use my friend assert equals table to make sure that those two tables contain the same data. I have built my test, and when I run my test, you'll see that everything looks fine. The structures are the same. We are all happy until one day somebody comes along and they saw my stored procedure and they said, you know what, we didn't like that child name being a varchar 250, whatever it was. We want it to be a varchar 99. And so they modify my stored procedure, those jerks. And now, all of a sudden, my test fails. And it's telling us these columns are fine. 1, 2, and 4 are just fine. But look, we expect on the left a varchar 255 that is not null. And what we're getting is a varchar 99, which is nullable. So the data contract is broken. And my test will tell me before my customer does. Very important that the customer says, I expected this very wide string and I did not get the wide string. Another thing that the guy does, he's a junior dev. I don't like this guy, but he's modified my demo child table and he's changed the sum date. He thinks that it should be nullable now. And so my stored procedure is going to return something that also I didn't expect. The first two, columns 1 and 2 are fine, but it's telling me also now that sum date, I expected it to be not nullable, but now it is. Sum date is nullable now. So if anybody does anything to my code and it breaks this data contract, I can prevent that from ever going out to the production servers. And it might seem like a little thing, oh, you've made this string a little bit shorter. Trust me, it's not a little thing. If you have an agreement with your customer that this is what you are going to provide from the output of a stored procedure, you need to guarantee that that's what you provide. And this test can make sure that you don't break that contract. This is how I was able to go through and rip out 45 different views and know that my customers were still getting what they expected. This and some other tests as well. They did some logic tests, but that was the primary part of it. Now that pretty much brings us to the end of my demonstration, but there was something else that I wanted to bring up briefly about writing good tests and designing your database. You'll notice that most of the default output of these tSQLt tests is to write to the console. I guess what would be considered the console. I call this the console because I tried to redo my presentation using the great Data Studio the visual code-based one, the new one that can do the runbooks and stuff. It's really great, but the printed output that it does here is in a proportional font, and you don't have the ability to change it just yet. I have got a feature request in with them. It's got my name on it to say, please let us pick the font. And this looks horrible in a proportional font. But the other thing to bring up about that is this printed output is notoriously difficult to capture, the same as like a record set is notoriously difficult to capture. And that isn't really related to these tests as much directly to that. A while ago, I was working on a feature, and another developer and I were discussing different ways to do it. And they wanted to have a flag for like, don't actually do this thing, just show me the text that you would return instead. So it was going to create some dynamic SQL, and if the flag was set to true, it would print the text for you. If the flag was set to false, it would actually execute the test, the code. And he wanted that all as part of the same stored procedure. And I argued against it. And I argued against it because I said it's really tough to test that. It is tough to say, grab the output that is printed to the screen and tell me that it is what you wanted to do. And my argument was instead to have a stored procedure that generated the dynamic test and returned it as a output parameter that could be captured. And the reason I wanted to do it that way was because I can test that. I can call the stored procedure, I can grab that parameter and evaluate that the data inside that parameter is what I expected. And that took my one stored procedure and turned it into two. And was it fundamentally better because we did it that way? I don't know. But I will say that it was a testable solution. And if you have the option of picking a testable solution over a non-testable solution, you should probably pick the testable solution. Your customers will appreciate it for sure. If you're running code and making sure that it works properly before they get a chance to do it. I think that's about all that I've got right now, guys. That is, hopefully this is useful for you. As you can probably tell, I'm very excited about unit testing and all the power that we've got with the tSQLt framework. I do thoroughly enjoy talking about it, and I would love to take any questions that you've got.
Well, Brian, thank you very much. I don't see any questions. I do have our friend who runs the Victoria, BC group, Janice Gerby, does a couple, she is very into tSQLt as well. So I will get you her contact information and you two can talk about tSQLt as well.
That'd be great.
That was a very good, exciting presentation about testing. So that was fun. And you obviously enjoy your topic. So thank you very much.
Sure. I appreciate the opportunity.
So again, thank you everyone for showing up tonight. Great that you made it out here. Don't hesitate again. Remember that email alias is leadership@oregonsql.org. Go ahead and send us emails. Let us know what you want to see. And hope to see you next month. Again, we're going to have Jessica Aguilera talking about the differences between her experiences with Power BI and Tableau. So anyone else on the leadership team want to say anything?
I just want to make sure to remind everybody that we'll be doing the raffle within the next couple of days and putting the results on our website. So keep an eye on our website. When it's updated, it'll have the winners.
Great. All right. Well, thank you again. And we are recording this meeting and we should have it posted on the website in a couple of days or so.
Thank you very much for the opportunity, guys.
Thank you,
Good night,
folks.
everyone. Thanks for the great presentations, all.
Thanks,
Yeah.
everyone.
Safe travels home.